This is a lesson about compound inequalities. As you can see, I have kind of a more complicated example. I've got two inequality symbols here. I have 3 is less than or equal to x, which is less than or equal to 7. So what this is saying is that we have this portion, 3 is less than or equal to x, and at the same time, x is less than or equal to 7. And that's what this means. So there's two parts. And if you feel more comfortable with this, you can flip this around as long as you flip the sign. So it's x is greater than or equal to 3, and at the same time, x is less than or equal to 7. So a number that would work would be, let's say 5. 5 is greater than 3, and at the same time, less than 7. But a number that would not work is 8. 8 would make this part true, but this part would be false. So what we're going to do is we're going to graph this first part here. So we go to 3, we put a closed circle, and we go to the right. And we go to 7 for this part. We put a closed circle, and we go to the left. And what we can do is we can see that, hey, this point is on both of the graphs, this point is on both of the graphs, and all of these points are on both of the graphs. So the end result is just going to be, when there's an and, it's going to be the overlap between the two. So the answer, or the graph of that compound inequality, would be closed circles at 7 and at 3, and a segment connecting the two. It can get a little bit more complicated, so let's say if we had 5 is less than x minus 3, let's go 2x minus 3, which is less than or equal to 11. So again, we're going to have two setups. We have this one, and we have this one. So we have 5 is less than 2x minus 3, which we then can solve. We're going to add 3. We get 8. I'm going to divide by 2, and I get 4 is less than x. I have the other side to take care of. I have 2x minus 3 is less than or equal to 11. I'm going to do the same steps. I'm going to add 3, which gives me 14. I'm going to divide by 2, which gives me 7. It's all separated by an and. So I have numbers, and if I flip this, x is greater than 4 and less than or equal to 7. You could rewrite it as 4 is less than x is less than or equal to 7. And you should be able to graph just from this. So see how x is in between the two numbers? So let's make our number line. What was that? So here's 4, 5, 6, 7. And I'm going to get right in there. And the 4 has no equal to part. So the 4 is an open circle. The 7 has the equal to part, so it's a closed circle. And it's all the numbers in between 4 and 7. So that would be the graph of that original inequality. And you can get as complicated as you want from there. You just have to do the algebra behind it. But wait, there's more. It's like an infomercial. Sometimes we're going to have two inequalities separated with an or. So we'll do a simple one, then we'll do a complicated one. 3x is less than 2. Let's go 12. Or 2x minus 1 is greater than or equal to, let's go with 11. So we're going to go ahead and we're going to solve these independently. We're going to divide by 3 on this one and get x is less than 4. we maintain that it's OR. We add 1, we get 12. We divide by 2, we get x is greater than or equal to 6. So this is a little bit less exclusive. It can satisfy either of these conditions and be a solution. So if it's less than 4, or if it's greater than or equal to 6, we're all set. So I'm going to graph. Here's 4, call that 5, call that 6. So it could be any of those numbers or any of these numbers. So generally speaking, if it's an OR, the arrows point in opposite directions. If it's an AND, the arrows point in the same directions. And that's a look at compound inequalities.